Alright, so what we have here is the Kadane algorithm. What this question is asking us is to compute what's the maximum sub adjacent numbers. Adjacent numbers are the numbers touching either on the right or left. So you have this, what's the sublist which can produce the maximum amount of numbers of value if you add them, sum them all, and what's the value, right? One way to solve it is thinking about the temporal sum and also the math amount of sum. So if we iterate over every element, what we can do is that we add them. We don't have to know what the numbers on that list are, we just need to know what the value is, right? So in this case, what we can do is to calculate that by calculating the temporal sum, and that's going to break every time the current number is larger than that's when we're gonna replace the number, right? So let's just go into the example. So if we have, for example, 1 to -3 4 5, well, what we can have is that it says 1, then we have 3 here, and we have a -3. So we say that we compare between this number and the addition of these numbers, which is going to be 3 minus 3, which is going to be 0, and we take 0 and we can compare 0 with the previous maximum, which in this case will be 3, and then we compare them together. Then 3 is going to be winning here, right? Because 3 is larger. Then what we can do is that we could then go to the next and we compare if 0 plus 3 is going to be larger than 4, and in this case 4 is going to be winning. So we compare the maximum, which is going to be 3 and 4, and after comparing that, we can say that 4 is going to be the largest number. So if we want to create the Kadane algorithms, so what the word compute is, first we iterate for every element. So we can say that for every, let me just test first if this works. I think this should be working, but sometimes I write wrong in or off. Yeah, okay, so this works. Yeah, just wanted to test that first. So we want to compare, we want to have in a variable the math all var, which is going to be that's going to be, ideally we have like, well, in Python you have a minus infinite. In this case I'm just going to write like, because I don't know how to write minus infinite, I'm just going to be writing let I equals to 0, I is less than array dot length, and we add I on every iteration. We want to actually start it with 1, because in this case we are going to start creating the math so far as equals to array dot I, and let math temporal, which is just the calculation between that and the previous one. That's going to be also array I. Alright, 0, sorry, it's not defined. So here we want to do math temp is equal to math between the current number, or the current number plus the match, the temporal match, right? And in the other way, we're going to, in the other hand, we're going to compare if that temporal match is going to be larger than the existing match so far and the match temporal, right? And then at the end, we want to return the match so far. I think this should be enough. Yeah, that actually works perfectly. I'm going to be saving this.